Hi there, this is Professor Eckhouse, and I'm going to talk to you today about how to add and subtract fractions with a common denominator. Okay, we'll do unlike denominators later, but adding and subtracting fractions is harder than multiplying and dividing because you have to find a common denominator, but we're going to start out easy and already have them given to us. All right, so I have a polypad workspace right here that you can click on this and go see the things that I've done here and play with it. You can change it, it won't change mine. All right, so we're going to start with this example here. We're going to use models first, and then we're going to do it without models. So the models are given so that you can kind of come back and think of it visually. So use a model to find the sum of 3/8 plus 2/8. All right, so this one right here is 3/8 because we've got 3 shaded in sections and 8 total sections, okay? And the other one is 2/8, 2 shaded in out of 8 total sections. Now, if you take all of these and put them together in one, I get 1, 2, 3, 4, 5 portions out of 8. So as you can see, we just added the top and left the bottom alone because we don't change what it is divided into, and that really throws people. That is why we don't change the bottom. We're not changing how many it's divided into. Okay? So here's some rectangular models as well. So this one here is my 3/8, just like this was my 3/8. And this is my 2/8, just like this was my 2/8. And then I end up with 5/8 because I take these basically and move them up there. Okay? All right, so that's modeling. You're going to see some problems like this in the homework. You're going to see some problems like this. I just wanted to make sure you saw it. So let's think about this. We want to write a fraction that represents the sum of the shaded area of the fraction circles. So imagine I just had 2 circles drawn on a piece of paper and I had some pie-shaped pieces of plastic, right? And I had them separate like this. Well, what if I just took this one and plopped it over there? So first you've got to think about what is the denominator of each? Are they the same? Well, so let's look. 1, 2, 3, 4, 5, 6, 7, 8. That's the denominator of this one. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8 here. Count carefully, goodness. All right, so they're both the same. So that means that this pie shape will fit over here. And we want to make sure it fits because it's 1/8, right? So what does this represent? Well, this represents if I moved it over, this one would then be shaded in. And I've got 1, 2, 3, 4, 5 shaded in out of 8. So I've got 1/8 plus 1, 2, 3, 4/8 equals, that will come together to be 5/8. Okay, so you've got to think about the numerator and what you do with them. What is the numerator of each? Well, the first one was 8, the second one was 4. What did I do to them? I added them. Is the denominator the same in both of them? You got to check. Okay, so check those kind of things. Make sure you make sense of the picture. All right, so we're going to add fractions with a common denominator with no model. So here's the definition. If A, B, and C are numbers, if you have A over C plus B over C, then you get A plus B over C. Okay? All right, so to add fractions with a common denominator, add the numerators and place the sum over that common denominator. So here's how we're going to do it. We're going to have 1 plus 3 over 7 when we add these two, 1 over 7 plus 3 over 7, and we just get 4 over 7. All right, you try that one, see what you can do with it. All right, hopefully you see that the top is just going to be x plus 3, and the bottom is going to remain 4. Now we can't combine x and 3 because they are not like terms, so we're just going to leave it like that. All right, next one. Try that one. All right, so one key thing to remember here is that negative 5n is the same thing as negative 5 over n plus 2 over n. So now we've got negative 5 plus 2 over the common denominator. Negative 5 plus 2 is 3. N stays like it is. All right, so a negative sign on a fraction can be written in any of those locations, remember, beside the numerator, beside the denominator, or out in front. So don't forget that. We talked about that last time. All right, so find the sum of this one. See what you can do with it. right, so we've got 3x plus 6x on top over 13. Well, 3x's plus 6x's, remember, is just 9x, 9x's, if you want to think of it that way, over 13. All right, let's try the next one. So pause the video and give that one a try. All right, so we've got two negatives adding together. So I'm going to rewrite this as negative 3 over 8 plus negative 1 over 8. So that's really what's happening. The negative is on top for the sake of this problem. It just makes it easier to think about. Okay, so, and if you put it on the bottom, it wouldn't make any sense, really. Not really. Wouldn't be able to add the numbers. So when you've got negatives with fractions that you're adding or subtracting, you want to bring the negative up to the top in the numerator, so you can work the problem. All right, so we've got negative 3 plus negative 1 over 8, and that gives me negative 4 over 8. Now, does that simplify? It does. So we've got negative 4 times 1 over negative 4 times 2. The 4's are going to, I'm going to put the times 1 just so you can see that there's still a number there, negative 1/2. Okay, so that becomes negative 1/2. All right, try the next one. All right, again, you need to rewrite this as negative 4 over 15 plus 14 over 15, so you can add the numerators properly. Negative 4 plus 14 on the top over 15. Negative 4 plus 14 is 11. Nope, it's 10. Sorry, it's 10 over 15. 10 over 15, 10 has 5 times 2, and 15 is 5 times 3. The 5's are going to divide out, and I'm going to get 2/3 as my answer. Okay, so model fraction subtraction. If you had 7/12 of a pizza and somebody ate 2/12, how much would you have left? So imagine I could color these, which I can't, but if they were interactive, I would take this one and turn it into not a shaded one, and this one not a shaded one. Okay, so that means that we have 1, 2, 3, 4, 5 left. So what did we do? We took 7/12 and we subtracted 2/12, right? So somehow we got 5/12. We're going to look at that. All right, use fraction circles to find the difference. We've got 4/5, 1, 2, 3, 4 out of 5 minus 1/5. So if I took this away, I have this one, and this one left. So I get 3/5 left. 4/5 minus 1/5 is 3/5. Also know how to use the fraction bars. You may see those in some of the problems. So here we have 1, 2, 3, 4/5. And if we took one away, I would have 1, 2, 3 left, 3/5. Okay, so 4/5 minus 1/5 equals 3/5. All right, so you may see some like this, and I want to make sure you know how you understand how to use them. There's no number. You're going to see them with no numbers. So this won't be here. So imagine that's not there, and you have to do this. Okay, so write your answer as a reduced fraction. All right, so let's figure out what's going on here. We're going to take this one, the blue one, and subtract the red one. So first we have to make sure they're divided into the same parts. 1, 2, 3, 4, 5, 6, 7, 8. So this is out of 8s. 1, 2, 3, 4, 5, 6, 7, 8. This one's also out of 8s. Okay, so this is saying that this red one here represents one that's going to go away. This red one represents one that's going to go away. And this red one represents another one that will go away. And how many do we have left? So we started with 5/8, we subtracted 3/8, and we have 2/8 left. So it's kind of hard to show subtraction without an animation, but that's what they're trying to show with these, okay? All right, so fraction subtraction, as you've probably already figured out without a model, is just going to look like this. A over C minus B over C is A minus B over C, just like addition. Okay, so let's find the difference on these. So 17 18ths minus 2 18ths is 17 minus 2 18ths. 17 minus 2 is 15 18ths. Oh, and look, we're supposed to simplify. So 15 and 18 both have a 3 in them, so I get 3 times 5 and 3 times 6. And the 3's are going to divide out, and I'm going to get 5/6. All right, next one. What would you do with that? Give it a try. All right, hopefully you see that you're just going to take the top and say b minus 2 and put the common denominator on the bottom, and there's nothing more you can do with that. All right, the next one, very similar to what we saw before, but we've got negative 8x minus 3x. So I'm going to rewrite this as over x, minus 3 over x. So let's rewrite that as negative 8 minus 3 over x. Negative 8 minus 3 is negative 11 over x. Be careful when you have a negative minus another number. It's the same thing as negative 8 plus negative 3, right? So this means that. Negative 11 over x. All right, give that one a try. See what you can do with it. All right, so I've got 11/12, and I'm going to rewrite the negatives so that you can see them. Negative 3/12, and then we're going to have minus 5/12. All right, so let's rewrite this as 11. So plus a negative 3 on top. I'm going to write, well, no, I'll just leave it. I don't want to confuse you. Plus negative 3 minus 5. Remember, plus a negative and minus is the same thing, all over 12. All right, so that means basically 11 minus 3 minus 5 over 12. Go from left to right. Don't forget 11 minus 3 is 8. 8 minus 5. So I just did this for those who want to take this one step at a time. And if you can do it all at once, that's fine. 8 minus 5 is 3 over 12. Oh, I've got 3 over 12. Let me make sure I did that right because I don't have a key. 11 minus 3 is 8. 8 minus 5 is 3. Okay, 3/12. So 3/12, I know they both have a 3 in them. So I've got 3 times 1 over 3 times 4, and I get 1/4. All right. And that is the end. It's looking like. Thanks for watching.